Hello everybody and welcome back to the next Learn Calculus video. Before we start, I just want to give a quick thank you to the people on Reddit that I went and posted in several subreddits asking people to look at this, look at what I've been doing and tell me things that maybe I could do better or things that they thought, maybe constructive thoughts, or if they just wanted to tell me if they liked it or if they didn't like it. Anything is appreciated and many of them are fantastic. I'm so thankful to the people that gave constructive criticism and that people that still are giving constructive criticism because I am taking it all in. I am not neglecting or anything like that because what else would I be able to do if I couldn't take any criticism about this, right? I'd be stuck in the same spot forever. It's you guys that make these videos possible and make it enjoyable for me to do it because I can tell you what, the moment that that view counter started going up on any of my videos, immediately outweighed any number of enjoyment that I had got by just making it, and it's only made it better, and I cannot be more than happy to say I'm more energized and determined to keep making these videos than ever before. And it's all thanks to the people on Reddit or the people that liked the video simply or watched it even. A simple number behind a screen can turn into a real person in a matter of seconds for me. And that is incredible. And I hope that over time we'll be able to cover stuff like physics or engineering courses like fluid dynamics or even just algebra or basically something as simple as an astrophysics course or a modern physics course, higher level calculus, graphing theory, all these things that are stuff that I want to do, and I'm so thankful to everybody being supportive and everybody giving me their thoughts. I am practicing right now in this video. I'm going to put some of the things that people have said into practice. Some of it was just as simple as get an editing software. Unfortunately, I'm operating on a little bit of a shoestring budget right now, but I'm doing the very best that I can to deliver good quality videos to you guys. And I just want to say thank you. Thank you to everybody. And it means the world to me. It really does. It means everything. Thank you so much, everyone. Now let's jump into today's topic. Today's topic is the chain rule. Oh, sorry, let's scroll that up a little bit. Today's topic is the chain rule. Now, in order to say that we can really understand the chain rule, we need to know some things about it. I've broken down kind of into three key points here that we're going to cover, and hopefully by the end of this video, you'll understand relatively in depth. And if not, I will end up posting possibly a video with a longer workout example of what we're going to be doing, because the one in this video is going to be kind of simple to just sort of get the point across. Mostly, it's a concept that if you can copy and paste it into things, you'll be able to succeed with it. But we need to understand what it is, like what the formula is, or where we get it from, or even something like that. Then we would need to break it down as to when we would use it, because we don't just have this thing for no reason. We don't just have it because we don't need it or because it makes things a little bit easier. It makes things very easy, but we need to see when we would use it, the appropriate situations. Like we know that if we are multiplying two parts of a function together, we would need to use the product rule here. Well, when do we need to use the chain rule? How does it work? We need to know how it works, so I'm going to do a little bit of an example for you to just kind of break down the barrier here, the barrier to entry, because it's really daunting because there's a lot of different U's and D's in there now. So we're going to be getting into some sort of stuff that may be a little bit uncomfortable for people, but that's okay because we're going to end up working through it together. Okay? And if anybody needs anything in the comments, I'm more than happy to answer any questions, help out with any homework problems that a student may have, give any hints to things if somebody doesn't want to just work through it with me. I am more than happy to provide anything. The same goes for anybody on Reddit. If you need help with anything, my name on Reddit is learning capital L learning underscore capital C calculus underscore. Message me, private message me. I don't care. Tell me the problem. I'll help you out the best I can. If it's out of the realm of something I could be able to tell you for certain how to do 100% effectively, then I will tell you because I'm not perfect. There are gaps in my knowledge, there's gaps in everybody's knowledge, but we'll do it together. I really hope that we'll create a strong community together. Let's get into this, all right? So what is the chain rule? We need to know what is this thing? Okay. Well, the chain rule, the easiest way to break it down is if you were taking the derivative of f of g of x. Yeah, right? F of g of x. And I know what you're thinking. That does not make any sense. Well, first of all, the way we would denote this whenever we're doing this is we would say it is going to be parentheses f open circle for contains g prime of x. Yeah, it's all in terms of x, but f contains g. Now, what is this? What does that mean? Because that doesn't make very much sense right off the bat, right? Well, essentially, the chain rule says that if f and g are both differentiable, then the composite function, so basically the combined form of capital F of x, again, we use that to denote any time that there's multiple terms for functions, the composite function is going to be equal to f of g of x. And that's just sort of a cleaner way to write it. In doing calculus, we're always interested in this, right? Basically, this chain rule then becomes, in its most simple form, we have f prime of g of x, right? And I know this isn't going to make much sense, but we'll get there. And once we start sticking some numbers in here, it's going to be a lot better. Trust me, okay? We have f prime of g of x times g prime of x. And some of you may be saying, okay, well, I think I can kind of already visualize what's happening. If we have a thing containing a different thing, we take the derivative of the thing on the outside, keep the thing on the inside the same, and then multiply. Sorry, that looks like a little subtraction symbol. Multiply the derivative of what's on the inside. So we treat the inside as a constant until we take the derivative of it itself and then multiply that in. Yeah? Does that make sense? Because having said this, we can then translate this into a differential form because you guys know I said it in my other notations video for derivatives. I much prefer the differential form of a derivative. Much more because it's very clear about what you need to do. If you can read the operator, that's the key, is reading the operator. It's very, very, very clear about what you need to do. So we have dy dx, right? Equals dy du. See, this is what I was saying. Now we're bringing in the u's. This is where people are going to probably get confused. Bear with me and I'll explain. Times du dx. Right? Okay. Let me break this down for you. So that way it makes a little bit more sense because some of you may be like, whoa, I I don't remember you being anywhere involved in taking a derivative for me so far. Unfortunately, if you're not comfortable with this, it's going to be something that shows up a lot, especially whenever you do integrals, because there's a thing called U substitution, which is basically the reverse chain rule. So we really, 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 it's important that we understand these concepts now, because much like in physics or engineering, all we do is build from here. That's all we do is we're laying the groundwork and then we build. So it's important that we understand this. What is this? This, again, is analogous to that, and this is analogous to that. And why I'm saying it like that is it's sort of just easier to understand it in general that way. So if we think of this in terms of y, so our f of x function maybe is our y, right? And if we treat our g of x as our u, we are taking the derivative of the y function with respect to u. So we're taking this derivative, but with what's respective of the outside, right? We're taking it of the respect of the outside. And then, whenever we get over here, we have our u function, and we're taking that with respect of the x that's in there. So we're taking the derivative of just g of x here. Does that make sense? This is just saying we take the derivative of the inside, because on the inside is a u function. And then on this, we take the derivative of the outside, because that's the y function of our examples and everything that we will do from here. Does that make sense? Remember, just like we did with the quotient rule, low d high, high d low over low squared, this you could say d of in, I mean d of out, d of out, keep in the same d of in. Yeah? It's less catchy, but it's a way to remember it. So we've checked off our first box, right? We know what the chain rule is. We know what it is, what the formula is for it. But when would we use it, right? What color should we do this in? Let's do it in blue. When do we use this? Well, it's sort of tricky because sometimes there are very clear times you should use the chain rule, and sometimes there are other not so clear times when you should use the chain rule. Most of the times when it is not clear comes down to order of operations. Have you done what you needed to do first? Because if not, then it messes everything up and you get weird stuff. And we don't like weird stuff. Numbers are supposed to be concise. However, it is cool when they aren't, but in order for us to comprehend it, they need to be. So let's look at this, right? When do we use this? Well, because I'm going to go ahead and kind of go ahead and set up a function that we're going to work out here in a little bit, right? So let's say that we had, composite function, capital F of x, right? The two things together, which is, we're going to go ahead and do f, so we got the circle f of g times x, and then that is that, right? So f containing g of x, right? So if we say that our composite function, f of x, without taking the derivative yet, is equal to the square root of x squared, square root of x squared plus 1. If we say that this is a perfect time to use the chain rule because I don't know about all of you, but I absolutely hate radicals. Radicals are my number one enemy. My number one enemy used to be trig, but now it's my best friend. Radicals, though, are forever, in my mind, the worst. I can't stand them. So we have a rule now. We have a rule that allows us to deal with the radical. And that is awesome, right? We can just get rid of this thing. But the main reason that we can get rid of this is we have to think in terms of exponents as well as radicals. So being able to recognize that a square root is a 1/2 power or that a cube root is a 1/3 power, anything like that is extremely important, right? Anything like that is extremely, extremely, extremely important. So if we take this and we say, all right, well that is the same capital F of x is the same thing as x squared plus 1 to the 1/2. Because if you were to plug into a calculator and take the 1/2 power of something, all you're doing is taking the square root, basically. That's the same exact thing. A cube root is a 1/3 power, a fourth root is a 1/4 power. If you have a radical to a power, you can transmit that into a 1 over whatever root you're trying to find for an exponent. So that's like saying if we had cube root of x, that's equal to x to the 1/3. Is that clear? If that's not clear, I can make a video about that just entire thing, but let me know in the comments, and we'll keep this going. So let's see here. We have capital F of x is equal to x squared plus 1. I left out the 1 somehow. Plus 1 to the 1/2, right? We have x squared plus 1 to the 1/2. This is where we use the chain rule, because if we think of this, we have our f of x. We now have our f, which is out here, of g of x, right? Right? Does this look like what we have up here? We have something inside of a parentheses that we have a function of, and we have, well, we have a coefficient here. Remember, we can treat an empty space out front of a value as a 1, like a coefficient of 1. So we have an outside value that we take the derivative of, and an inside value. So let's look at that, all right? Let's go through this again. So let's take our capital F prime of x. So we have now an outside, and it's important to recognize what is on the outside. The outside is everything outside of your parentheses. Nothing inside is going to be used. Nothing inside is going to be used. It's only the outside, including exponents, because an exponent, as you can very clearly see, is on the outside of the parentheses. So what do we do when we take a derivative? Well, whenever I taught the power rule, we multiply the exponent times the coefficient and decrease the exponent by 1. Yeah? So we get then 1/2 x squared, because we keep our inside the same, right? Keep our inside the same, then subtract 1 from the exponent, we get negative 1/2. And then we take the derivative of the inside. It's time to do our g prime of x, because remember, f prime of x is equal to f prime of the outside here times the derivative of the inside. So let's take the derivative of the inside. So let's put a little multiplication symbol here, a little dot, and then take the derivative. Well, it's just 2x, which is thankfully fairly easy to do, right? Now we need to do our formatting, and formatting is where we could tend to get sloppy, but it's important that whenever you do math that you don't get sloppy, because you will lose where you are and what you're doing very quickly. Hopefully you've realized this by this point in your math career, but if you haven't, quick refresher, it's important to keep your notation clean, and it's important to know what all your notations are, because that is the boundary between a great math student and an unfortunately lackluster math student. Is knowing your material. It's knowing the material. So if we know here that this is a negative 1/2 power, well, that negative in front of that exponent means that that's going in the denominator. This parentheses that it's working with, going in the denominator. So we already have, let's go ahead and write our 1/2 separate. Let's go ahead and break this up. So we have a 1/2, 1 over, and we can go ahead and reformat that as the square root. So we have a square root of x squared plus 1, x squared plus 1, times, again, the 2x that we had out here, that because we took the derivative of the inside. Now, if we go down again, we can start combining this stuff and make it a little bit easier, because this step was really just to recognize that this was in the denominator because of that negative exponent, right? So let's go ahead and rewrite our composite f prime of x is equal to 2x, because that's the only thing in a numerator right now besides a 1, but we can ignore those ones, times 2 is the square root of x squared plus 1. Our 2's cancel, right? Our 2's cancel because luckily, very, very luckily, uh, all of our stuff was multiplied together and then divided, so anything that we have together there we can cancel. So we have f prime of x, or composite f prime of x, is equal to x over the square root of x squared plus 1. Is that clear to everybody? It's imperative almost that we understand this. Why this was this way. That this is in fact understood by us and makes fairly decent sense. So just remember, if you have a function with a parentheses on the inside that you need to take a derivative of, and there's no external things, and I can make another video about an example where this might be a little bit more complicated, something that we can work through together, maybe with some trigonometry, because as you know, I like trigonometry. I say it almost every video. I love trig. I'll do that. I can make another video where we look into that and have maybe even 2 examples, just that way we can really get this under control, because I know that du is going to keep popping up unless you familiarize yourself with it. It is going to get you. That du makes sense. We need to make sure that all makes sense, because otherwise you can't learn. And if you aren't learning, I'm not happy, because I'm not doing the right thing then. And if you are learning, then that means that we understand stuff, and that's great. And with that being said, I'll post this video, maybe get started on this other one. All right? And I'll see you guys in the next one.